Hello everyone, welcome to my channel. In this video, I will explain about independent component analysis. So this topic belongs to machine learning subject. So first let us see the definition. Independent component analysis is a machine learning method used to separate mixed signals into original independent signals. Okay, so what is going to be happened in the independent component analysis? It is used to separate mixed signals. So what is going to be happened in this? The signals could be combined, okay, and it is going to separate original independent signals. Okay, so what is the main purpose of this ICA? So independent component analysis, in short we called as ICA. So the purpose of this one is it is used to separate mixed signals into independent signals. Okay, so let us say there are 5 or 6 different signals are there. When it is mixed, it is going to be separated by independent component analysis. Okay, now we'll see what is the purpose of this ICA. So especially ICA commonly can be used in audio. Okay, so second one is the image processing, and the third one is the medical signals. So we'll use this independent component analysis in audio, so as well as image processing, as well as this medical signals. Okay, so now I will see more. ICA finds hidden components from mixed data by making them statistically independent and non-Gaussian. Okay, so generally what will be happened with ICA? What is going to be happened? It finds the hidden components, so from the mixed data. So whatever the data is there, it is a mixed. ICA is going to find the hidden components by making them statistically independent and non-Gaussian. So what is the meaning of this statistically independent? So you see, if there are two variables are there, that is x and y. So two variables are x and y. So how we say, what is the formula regarding this statistically independent? That is equal to p of x intersection y is equal to p of x into p of y. So this is called as statistically independence formula. This means knowing one does not affect the other. Okay, so what is going to be happen? Any number of signals are there, one signal will not be affected on other signal. Okay, so now a second one is called as non-Gaussian. So what is the meaning of non-Gaussian? It does not have bell shaped. Remember all of you, when we say Gaussian, it is having a bell shaped, but when we say non-Gaussian, it does not have bell shaped. Its values may be uneven, skewed or irregular. Okay, so this is the formula for statistical independence. But if we come to non-Gaussian, the formula is f of x not equal to, okay, so remember the important point, not equal to 1 by rho square root of 2 pi e minus e power minus x minus mu square by 2 rho square. So this is called as a non-Gaussian. But when it comes to Gaussian, instead of non-equal to, just equal will come. So when I say non-Gaussian, just we'll have to use a not equal. Okay, now we'll see the assumptions of this ICA. So what is going to be happen in general? Source signals are independent to each other. Source signals are non-Gaussian. So this is the formula for ICA, that is equal to S is equal to WX. So what is the meaning of S? S is the separate independent signals. What is the meaning of W? W is the transformation matrix, and X is the observed mixed signals. One of the most important problem regarding this ICA, that is cocktail party problem in ICA. Okay, so what is going to be happened in the cocktail party problem? You see, to better understand how ICA work, let look at the example known as cocktail party problem. Okay, so this is an important diagram related to this cocktail problem. You observe on the screen here, there are completely 5 sources are there. First person source, second person, third person, fourth and fifth. There are 5 microphones are there. First one, second one, third one, fourth one and fifth one. So if you observe here, when the first person or source one speaks, what is going to be happen? It can be go to microphone 1, it can be go to 2, it can be go to 3, it can be go to 4, it can be go to 5. So similarly, when you observe source 2, this is also connected to microphone 1, 2, 3, 4, 5. When it go to source 3, it is also connected to 1, 2, 3, 4, 5. So source 4 also will be connected to again 1, 2, 3, 4, 5. So source 5 also similar. So 1, 2, 3, 4, 5. So what is going to be happened in this? This source 1 is connected to all microphones. This source 2 is connected to all microphones. So on up to all sources will be connected to all microphones. So what is going to be happened? We need to find out where is the actual voice of this source 1. We need to find out only the voice of source 2. So on up to we need to find out the source of 5. So this is called as what we say ICA cocktail problem. So remember all of you, this is called as cocktail problem in the independent component analysis. Okay, so when you observe this one, the problem is here, the signals are mixed. So what is going to be happen? Source 1 can be connected with all microphones. You observe here, source 1 is connected to all microphones. Yes. So similarly 2, 3, 4, 5. Now you observe here, what is the meaning of cocktail party problem in ICA? At the top 5 sound signals. So at the top 5 sound sources are there, source 1 to source 5. These represents the different people speaking. Okay, so these are called as a different people speaking. Then what is going to be happen? At the bottom there are 5 more microphones are there. Yes, microphone to micro 5 record sounds. Each microphone receives sound from all sources, not just one. So the crossing lines show that every microphone captures a mixture of all voices. Okay, so these are called as crossing lines. Every microphone capture all the sources. Then what is going to be happen here? You observe. Now we'll discuss about the problem regarding this independent component analysis. So you see, each microphone records mixed signals. Okay, so when you observe microphone 1, it mixture the all sources. When you observe the microphone 2, it is also capture or mixture all the sources. Okay, so then what is the main purpose of this ICA? This independent component separates, okay, mixed recording signals into original independent voice. Original independent voice. So what is going to be happen? What is the use of this one? We are going to access original voice to each and every source person. So recover source 1 voice, yes, recover source 2 voice, and recover the source 3 voice, and so on. So after completion of this independent component analysis, we are going to recover all the sources individually, all the voices. So let me conclude that source 1 voice could be clearly identified, source 2 also, so on up to source 5. So this is called as what we say independent component analysis, in short we called as ICA. Okay, so thank you for watching this video. Please subscribe my channel. Thank you one and all.